So the first step in making the pickups here is all the plastic bobbins. I'm taking sandpaper and sanding all the little rough edges from the molding process off because there's little jagged pieces of plastic and things left over from the mold. And if you don't sand them off when you're winding the coil wire, it'll break really easy because it's only about as thick as a human hair. So sanding all the sharp edges off the bobbin. Then I'm getting the start wire for the coil and trimming it, and I'm going to solder it to the lead wire of the copper wire that you don't see down below, but there's a spool of copper wire underneath the workbench, and then I'll start turning it to about 10 turns or so on the coil before I turn the machine on and let it wind the rest of the way. Now I'm just setting up the machine for the correct number of winds. For a typical PAF humbucker, it's 5,000 winds per coil. So I program it so it'll stop exactly at 5,000 winds. One thing you'll notice on there too, I don't know if you can see, but there's a black wire. The black lead wire is actually wrapped around the coil first before, or around the bobbin first before the copper coils are added. That's one of the few things that makes a PAF different, is that black lead wire is underneath all the copper winds. And so when the pickup's done, it actually creates a little air gap in there. And some people say that, that air gap is what contributes to some of the microphonics in this different sound of a PAF versus a traditional humbucker would be where they wind all the coil, and then the little tiny coil wire is soldered outside of the bobbin. It's not the lead wire, the thicker black lead wire is not wound around the bobbin. So that's one thing that's different. Here you see I'm just holding tension with my right hand and winding the coil, moving back and forth between those two little guides to make sure that the coil is wound. This is what they would call scatter winding, where you do it by hand and just try to spread the copper. So I keep stopping it every now and then just to make sure the copper is winding pretty evenly across the bobbin. Nowadays, there's machines that do it, and the machine wounds are perfectly even. But a lot of folks will tell you when the copper is wound perfectly even, it kind of dulls the pickup sound a little bit and gets rid of some of the highs. Whereas when you scatter wind it or do it by hand, you'll have a lot more harmonics and highs in your signal. So now that the coil's done, I'm actually soldering on the lead wire to the end of the coil. So there's a lead wire at the beginning of the coil and a lead wire at the end of the coil, and these are what gets soldered on to the main wire to hook up your pickups to the control cavity. So I just wrap the copper wire around this lead about 10 times, solder it, then I put a piece of tape over it, and then I'll wrap the coil to kind of hold everything in place. And the two lead wires, one from where the copper started and one from where the copper coil ended, will be sticking out the end, and that's what gets soldered to the wires that go to the control cavity. Here I'm just checking the output of the coil. Most PAFs have a pretty typical range as far as the impedance on the coil. And so this one, I think I showed on the tape, I'm trying to remember what it was, like 3.6 to 3.75, somewhere in that range. Yeah, 375 to 380 is the impedance, which is right in line with what typical PAF humbuckers were. Here I'm just pushing the slugs into the slug bobbin. There's a slug bobbin and a screw bobbin. The slugs just get pressed in, and then the screws obviously get threaded and screwed in. So here I'm just pressing the slugs in, and then I'll do the screws. And then I think my camera screwed up, so in the next clip you'll see me do it again on a different pickup because I bumped my camera and it's 15 minutes of video of watching the wall. So I redid it, so I think we're going to see the slug portion again. So there's the screws and the slugs are in again. Now I got this base plate, and the base plate has 6 screw holes that the screws go into, but they're not threaded. So I'm just using a tap and threading it. Different people use different size screws for the pickups depending on what they like. So that's why the screws aren't threaded yet, or the holes aren't threaded. So I got the standard PAF size screws, and so I'm just threading the holes. It's 540 is the screw size, which is what all PAFs were. So I'll thread the base plates and then I'll start putting it together. So the first part assembly here is taking the large braided wire that's going to go to the control cavity, and I'm just stripping the outside grounded braid away and then exposing the inside wire. But you pass it through a hole in the base plate here, and then you actually solder the outside of the braided wire to the base plate, and that's what grounds the pickup, so that's your ground. So that pen I use is just a flux pen for soldering. So you just drop a little bit of solder on the outside braided wire and just make sure you get a good ground connection to the base plate. Now I'm going to take the screw bobbin, the bobbin that had the screws through it, and I'm going to take the black wire, which is where the copper started at the very beginning of the winds, and I'm going to solder, that's a ground, so I'm going to solder that to the ground that I just made with that braided wire. Then I'm going to get, you see these little 4 brass screws, that's what's going to hold the bobbins to the base plate. That's another thing that makes a PAF different, is the screws are all brass, so they're non-magnetic. Most newer pickups just use steel screws, and anytime you got steel around the magnetic poles and the copper, it can affect the pickup. So again, that's just one thing that makes the PAF different, is the screws were all brass, and so brass can't hold a magnetic charge, and so it had less interference with the pickup. So I screwed the first bobbin on. It's still loose. You notice I just checked the magnetic polarity. That's an A2 Alnico pickup, and you need to have the south side of the magnet facing the screws. So you see I put the magnet down there, and then I screwed the bobbin in tighter to hold it in place. Now I'm putting the second bobbin in, and I have a little maple spacer that goes on the other side to kind of hold it flat. Again, that's another thing that's different. A PAF is they used wooden maple spacers back in the day. Nowadays, they're all plastic, or some of them even use metal, again, which will affect the sound of the pickup. So once I got the spacer in, then I put in the other 2 brass screws and tighten the bobbins down. Now the bobbins are nice and tight on the base plate. Now that it's in place, I'm just screwing in the screws the rest of the way through the bobbin and through the base plate. And this will hold everything in place. Now it's I'm getting ready to solder the other 2. So the 2 white wires will solder together. That's the 2 end lead wires from both bobbins. So that was the the wire where the copper coil finished. Those 2 will get soldered together, the 2 white wires, and then the last black hot wire you'll see, not the one that got soldered to the ground earlier, but the hot wire from the other pickup will go to the hot wire in the middle of that braided cable that I put down earlier, and then those pickup wires will be tucked in between the bobbins and then taped around the outside to keep everything neat and tucked away inside the pickup. Now the last step here is to add the humbucker cover on it. So what I'm doing here, I'm just sanding a little away the nickel plating away from where the solder is going to go, just to make sure it's a clean connection. And the cover just slips over the top, and then just a little bead of solder on both sides of it, and that holds it in place, keeps everything nice and tight. Then the very last thing I'm doing here is I'm just checking the output on the voltmeter and then the inductance. So the output is 4.3, I think, Henrys. They measure the output in Henrys, which is a better, more accurate way to check the pickup output than the actual ohms or the impedance, because it takes every